So we're given that the average of this non-decreasing sequence, which means if we add these all up, divided by n is 300. And because it's non-decreasing, A2 has to be greater than or equal to A1. They can be equal. They just can't decrease. So that's the condition. And so if we add these up, their sum is equal to 300n. Now if we replace A1 with 6A1, so we have the same equation divided by n is 400. So we get 6A1 plus A2 plus A3, AN is 400n. So I can subtract this equation from that, and we'll get, this piece will drop out, and we'll get 5A1 is equal to 100n. So A1 is really 20n. So that means that if each one, A2 will also be greater than or equal to 20n, A3 will be greater than 20n, and I know that their sum is 300n. So if I add up these, that has to be greater than or equal to n times 20n, because each one is 20n. And we also know that that is equal to 300n. So that puts a constraint on n. So n would have to be less than or equal to 300 over 20, which is 15. So n could be 15, 14, 13, all the way to 2. And the question is, what happens when it's 1? Well, 1 will not work, because if you have one number and A1 is 300, well, the average is 300. If you replace it with 6 times that number, this condition won't be satisfied. So we have to discard that 1. So n can be any value between 2 and 15 inclusive. That means we have 14 values. If you want to see this with an example of, let's say n is 2, we have A1 would be 20n, which would be 40. A2 would be 560, because their average is 300. Now, if I increase this to 6 times that, so now A1 is 240, A2 is 560, and you'll see if you add them, that's 800. The average is 400, so we do satisfy that second condition. And that will also be the case with 3, 4, 5. So the answer is number of possible values of n is 14, and that also means number of possible values of a sub 1, which is really just finding the number of possible values of n, is also 14.